Hello everyone, this is Edgin Montiel, and this video is for the CSWA that I have been working on with everybody. This is probably going to be one of the last videos that I do for it, so it's going to kind of summarize some stuff and then go over the assembly information that you guys need to know for the CSWA exam. I'm also trying a new screen capture program because my snipping tool was not working and I'm distraught about it. But now, so hopefully this one works great and we're going to find out. But I already got SolidWorks open and what we're going to be doing. I don't think I've sent this out this time around, but I will send it out after I make this video. But I have a actual practice exam for the SolidWorks CSWA. So the CSWA itself is a 3-hour test, and if you take it through UCCS, it's going to come in 2 parts. Each part is 1.5 hours each, so it's still a 3-hour test at maximum. You can always go faster. But this practice test is kind of an example, like a pseudo, like exactly what it is. It's a practice test, right? So this is going to make it feel like you're taking the real test, except this is half the length. So this one's only should take you an hour and a half at a maximum. So if you go to take this test and it takes you longer than an hour and a half, I would say that you definitely weren't ready to take the CSWA yet and practice on getting more proficient at some of this stuff. So the beginning of this practice test just tells you all about what's expected, what you should know, how long the test is, what you need to pass. This is a little bit different for us because we are taking the student edition. I think you can get an 80% on this one if I remember right. Just go ahead and read through this, but I'm sorry, it says a 70% on this one. At UCCS, the student edition, we have to get an 80% to be able to pass the test. Then when we actually go take the test at UCCS, we can use SolidWorks on the computers there. But we also need to install a separate software. So here's the link, and it walks you through the instructions on how to install this Download Tester Pro client. Because when you actually go to take the CSWA exam, you end up having to run SolidWorks, which is a program that you're running, and then you end up running this other testing client program at the same time, because the testing client is going to give you the instructions and how you submit your answers and stuff as you're taking the test, and that's how it keeps it timed as well. So you install this Tester Client Pro, and ultimately, if you're following CSWA here at UCCS, you need to get a hold of whoever is in charge of the CSWA stuff, which currently, right now, it's myself, Edgin Montiel, and then I work with Tucker Walsh at the machine shop because he's the one that has the SolidWorks login information for the entire school. So the way it works is Tucker enters your UCCS email address, and it gives you the ability to take these tests for up to 30 days. I believe Tucker's actually leaving UCCS, and it's probably going to get handed off to either Chris Goodwin, who is replacing Tucker at the machine shop, or hopefully I'm thinking it's going to go to Dr. Benjamin Wilcox. So they would be the ones that you would need to get a hold of going forward, to one of those 3 people to be able to get your email submitted into the portal so that you can take the CSWA Student Edition exam. And again, it's 2 different exams, an hour and a half each. But then, what you do personally is you need to have access to SolidWorks, and then you also need to install this Tester Client Pro software. I think we can install it at the school, to be honest. I'm pretty sure Justin did it the other day. Not to throw him under the bus, I won't say his last name, but we were able to get this software on the school computers, and then they already had SolidWorks on select computers. So you could do this all at the school, but I think running the tester client on like your own personal laptop, and then maybe using the school's computers to be able to do the SolidWorks stuff, having 2 computers at the same time has kind of been very efficient means of doing this. So you end up setting up kind of an account with SolidWorks, but you associate it with your UCCS email address. And then you ultimately will get to a screen that looks like this, and you'll find once you give your email address to UCCS and they enter it in, then you're going to be able to go in here for 30 days and be able to take the 2 exams. you can get this installed right away, and you can take this practice exam that I'm getting ready to show you right now. So you can take it as many times as you want to. It's timed. It is exactly how the test will be. So if you want to take it and know how it's going, how ask you the questions and show you the information, you can take this exact same practice test that I'm showing you right now through this testing client if you go ahead and get it installed right away. Just make sure to do it through your UCCS email address. If anybody has any questions about any of that stuff, I have installed it a couple times now, so don't hesitate to shoot me an email. I answer pretty quick. So again, my name is Edgin Montiel, and then you're watching this video on my YouTube channel, so hopefully you can find me. So the test, the CSWA, is going to be broken into sections. There's going to be conceptual, like sketching, drafting competency questions, and then there are where you make parts, and then there's like an assemblies section. The assemblies question is worth the most points, so definitely pay attention to the video when I get to that part of it here, because this is where I'm going to go over the assembly stuff. But I'm also briefly going to go over these draft competencies questions here, because on you will end up getting questions on this, and this is the only place where I know you can find this information. So then this one, to create that drawing, which one is it? This one was a broke out section, I believe, because you like took that away and you can see it without it. So broke out section. There's another one that was in the test that was like a horizontal split, or a horizontal break, I believe is what it was called. So other than like process of elimination, I didn't really know how to answer these questions any better, but they were kind of almost obvious because it gives you 4 options for each one. So you'll have questions like that, and definitely multiple choice. And then it's going to give you parts. This is an example of a part it will give you. I know this one looks pretty complicated, but expect that. It will be kind of awful like this, and you have to have a really good plan on building it. I already had a video for this one, so if you guys haven't had a chance to watch that one, I have some good tips and tricks on how to build something that's complicated like this. You just definitely want to try to look at the overall geometry and try to just save yourself as much time as you can on realizing um, shortcuts on this is all I could say. So the way that this test will work is that just like in the video where I made this part, it's going to have you make the part, then you answer a question about it. It starts off with multiple choice, so you should get the exact answer without a 1% error. So if you don't get their exact answer, I would try to fix it when you're actually taking the real test. So you need to be proficient enough at this to make this part relatively quickly, because if you don't get these exact answers, you want to make sure you have time to go in here and try to understand what you maybe did incorrectly, because there's a lot of information, right? You can accidentally enter something wrong here, or more realistically, the biggest mistakes that happen is you make an unnecessary sketch relation, because SolidWorks will make sketch relations on your behalf based on the way that you drew something, and it may not be something that you want. So it has you make the part, and then you end up having to alter it. So this is that same part, and it just ended up cutting away some of the shape to it, and then they alter it even further where they cut even more. They cut like a hole into it, this interior. So I have all that in another video. And then the last part of this test is going to be putting together this assembly. So a big part of SolidWorks and all my videos so far have just been on making parts and sketch relations and dimensions and how to bring all that stuff to life. But then once you make parts, you can put those parts together in what SolidWorks calls an assembly. And then the assemblies, because these are parts that could be made out of actual materials in real life, so they actually have like weight to them. SolidWorks can actually use coordinate systems and be able to calculate where the center of mass of this assembly is actually at, which is actually pretty fascinating because if you were to try to do the same problem by hand, after having learned it at UCCS, it's quite awful. And it's cool that we could just kind of put this stuff together in SolidWorks, and it takes into consideration all of the geometry and the weights of each one of these parts and their orientation with each other and how they're connected and how they sit on some reference frame. In this picture, we can see that what they're going to ask us, questions 7 and 8, is they want us to determine the center of mass of this assembly based on the coordinate system as it sits right here. So this thing, if you were to weigh it, it weighs a certain amount, and you could balance it somewhere in the middle of it, is the way center of mass kind of works. So the center of mass has to be described in 3D space somehow. and they do it with a Cartesian coordinate system. That's this X, Y, and Z coordinate system. It's the most common one. It's not always the easiest, but it's what SolidWorks uses. And we know they use the Cartesian coordinate system because it's down here in the bottom left-hand corner of the screen. So some of the people that are taking CSWA are not that far in their engineering careers, so I do want to go over some of the basics here. So I'm going to kind of go over what center of mass is, and I'm going to draw images in SolidWorks, assign material properties, talk about density and center of mass, and move it around a little bit to demonstrate how the center of mass moves on a Cartesian coordinate system. And if you're familiar with all that, I would recommend kind of skipping to where I actually start putting this assembly together, because it will definitely be redundant. Or if you want to hear about all of that stuff, I'm getting ready to go over it. So what I'm actually going to do here is, just like in physics, one of the easiest things that we can start with is a beam. And a beam, I'm going to make it all the same material, so it's going to be homogeneous and isentropic. So it's just going to have all of the same material properties in every directions, is what the way that SolidWorks analyzes things, and the way that I'm going to assign the material properties to this as well. So I'm also going to draw it very intelligently because I want to show you that the center of mass is kind of in the middle of a simple object, and then I'm going to move it around so you guys can maybe visually understand it a little bit better as well. So if I have an object, if you think about like a pencil, and you try to balance the pencil on your finger, because the pencil is pretty much a cylinder and it's almost all made of the exact same material, the center of mass of that pencil is right in the middle of it. So if you try to balance a pencil on your finger, you would hold it on your finger kind of in the middle to be able to balance it. And I'm going to show you the same thing in SolidWorks except with a beam. So in the middle in SolidWorks is going to be where X, Y, and 0 all equal 0, or X, Y, and Z all equal 0. So in here we have the front plane, the top plane, and the right plane. And all of these, where they intersect in the middle, you can't really see it because X, Y, and Z come together at one point, and it's where all three of these planes come together at one point as well. And that is where I want to kind of start this beam. So when I'm drawing in SolidWorks, when I'm picking this origin right here, this is where X, Y, and Z all equal 0. So I'm going to pick a center rectangle tool because I'm going to just bring this into life right on the origin. And I'm going to just make it some easy length, like 100 millimeters that way. And then we're going to do like 20 this way, sure. And then check mark, exit sketch. And then when I extrude this, I'm actually going to, let's see if I could turn on the planes so you guys can see them. Oh, I can. Right here, so we can actually see those planes and how that point is kind of in the middle. And I don't think we've shown this in a previous video, so I want to show you guys that you can actually extrude off that sketch plane, but we can go other options blindly. Oh, direction 2 is what I want to show you guys. So I can go in both directions, and I'm going to do that on this sketch just because I'm trying to keep that center of mass right on the origin as I'm drawing this. So I have ultimately the center of this object, this 3D object. When I'm looking at it in this direction, from left to right, it's in the center. When I look at it this direction, left to right, that point's in the center. So no matter which way I look at this, that point is always in the center of those surfaces. So as long as this material is made out of all of this exact same material, if it's a homogeneous or consistent in nature as its material properties, especially its density is the most important one, then that center of mass is going to be right in the middle of it. So I hit check mark, and now I have a beam. And I'm going to turn off those planes now because you can kind of see that they're going through it. And now I'm going to assign a material property. I'm just going to make it some kind of steel because we always make like steel beams. Alloy steel right there. Apply and close. Now I'm pretty sure as a part we can go to mass properties and look at the center of mass right here. So it's telling me that the center of mass is at x equals 0, y equals 0, and z equals 0, which makes total sense because I purposely built this right in the middle of the origin there. And here in the image on my sketch pane here on that gray window, you can see that that origin is right in the middle of my beam. So if I were to hold this right there, then it would be perfectly balanced, is what SolidWorks is telling me, based on the way that I drew it and where this coordinate system is. So, as we analyze things in the real world, we can put this coordinate system wherever we want. And when I draw things in SolidWorks, kind of same thing. I drew this one this way on purpose so that I can get 0, 0, 0. But I could also move this around and get different values on that. So now I'm going to go in here and edit my sketch because I have this pinned to the origin, but now I'm going to come in here and delete all of these sketch relations that are holding it on the origin. And instead, I'm going to make this corner touch the origin. So I'm just making a sketch relation between those 2 points, if it lets me. I don't think I clicked something incorrectly, maybe. Make those coincident. There we go. So now I put the origin on the corner there. It's not quite on the corner. It's still in the middle, but it's all the way to this left side. So just because I know what I'm doing, and if I look at this thing right here, it's still balanced in this direction, but in every other direction, it should be completely off. So let's go look at the mass properties. And you can see in the Z direction, so front to back, it is still right in the middle, so it's balanced in this Z direction. But in my X and Y direction, because now it's calculating the center of mass from this origin over here to the left, it is giving me these different values. So even though I didn't change anything about my beam, I changed where the reference point was of where it was actually calculating it from. Because the first time I calculated it, this little blue dot was in the middle. Now this little blue dot is right here. And this is where it's measuring the center of mass from, because the center of mass is 1 point. So it's trying to describe to me in a 3D space, Cartesian coordinate system, where that center of mass is relative to this point. So that's a big part of what you need to kind of understand for this assignment, because ultimately, any object or connection of objects, like when you put a bunch of things together, they have weight to it. And because they have weight to it, somewhere on or near those bodies, there's going to be 1 point that you need to try to describe a coordinate system for to tell SolidWorks or to tell the test, ultimately, right? Because we're trying to answer the test, where that center of mass is. So that's what a center of mass is. So this was all just a part. SolidWorks does want us to do this in an assembly as well. So I am going to make a assembly from this part. And it's going to make me save it first, even though this is just a beam. I'm just going to throw it on my desktop and call it beam. All right, so I saved it. I'm opening this up in an assembly. Here's the beam, and this is going to be the first part that I load into my assembly. Pow, there it is. So that's really important because the origin of the assembly and the origin of the part will match each other when you load them in this way. See how I can click on either one of those and they ultimately load in on the same exact point, and I can go to mass properties and evaluate it, and I can see that that value is still the same. So I am in an assembly right here. This window is looking at the assembly. I can go back to the part view. This is where I ultimately had edited this sketch and changed where the origin was. I'm gonna do it again. I'm a busy guy. So we deleted all those. Now I'm going to tell SolidWorks, I don't want to accidentally click something. So I'm gonna move this over so I don't accidentally click something I don't want to. And I'm gonna pick this middle point. Oh, it's gonna give me a hard time. So I want that point and this line to be coincident, and that point and this line to be coincident. Does it move it? Did I do it right? Oh no. Oh my gosh, there's like a point. We want the origin. So no, I was moving around a point. What I actually want is the origin. So the origin and this line are coincident. And the origin and this line are coincident. And now it should be back in the middle. Hopefully. Where's the origin? There it is. So when I go back to my assembly, It's going to have me rebuild it because I changed the part. But remember, when I load this in, it matches up their origins for me. Oh, and look, now it moved. And when I go to mass properties, it's 000 because I put it back in the middle. So I hope that helps you guys understand center of mass a little bit. And this video is already a little long, so I think I'm going to stop it here and make another one just for the assembly part, so that it's not super long. So sorry if you try to skip ahead because I told you that the assembly was at the end of this video, but it's actually going to be in the next video. And this was kind of just like an introduction to CSWA and what's going to be kind of expected on the test, as well as talking about center of mass. So I'm going to end this one here. Peace out, y'all.